To create a Git repository, you need a directory. Let's create a new working directory named project. Use the maker command for it. Then let's initialize a Git repository using a git-init command. Git-init automatically creates a hidden directory called .git. Here Git stores the metadata and object database of your project. It is the most important part of Git and is copied when cloning a repository from another computer. The staging area or index inside the Git directory is a file that contains information about which changes we are going to preserve. We will elaborate on this in a minute. Also, git-init creates a default main branch. Next, let's create a new file called file.txt. Now this file is added to the working directory. Please note that at this stage, the Git history has not been updated yet. The command git add is used to inform Git about the files that should be added to the staging area and included in the next commit. In this case, the file.txt is specified. This process allows for better control and organization of changes before they are permanently recorded in the Git repository. To save changes to Git, we use the git commit command. When we commit changes, Git takes a snapshot of the files from the index or the staging area to the Git directory, creating a new commit in the repository. The -m flag stands for commit message. It allows you to provide a concise and descriptive message that explains the purpose of the commit. By using the git commit command with a meaningful commit message, we maintain a clear and organized history of our project, making it easier to track and manage changes over time. So the basic approach to working with Git is as follows. First, you modify files in your working tree and select changes you want to include in the next commit. By using the git add command followed by the file names or patterns, you can add specific changes to the staging area. Second, you commit the changes, which permanently stores the snapshot of the files from the staging area in your Git directory. Third, when you need to access a particular commit in your project's history, you can use the git checkout command to retrieve that commit from the compressed database in the Git directory and bring it into your working directory. Working on an ML project involves making frequent changes and trying out different ideas. To manage this effectively, Git provides a powerful feature called branches. Let's take a closer look at how branches work using an example. Imagine an ML engineer named Anna. She's created the main branch in her Git repository. The main branch serves as the starting point for her project, containing the initial version of the code. Her colleague, Jack, is a data scientist. He needs to add a model training pipeline. So he creates a new branch called add_train by using the git branch command. Then, using the git checkout add_train command, Jack switches to the newly created branch. Once Jack completes the model training pipeline, Anne can seamlessly integrate his changes into the main branch using the git merge command on her local machine. Remember, to merge changes from another branch into the main branch in Git, ensure that you are in the main branch.